So, what we've seen so far is magic concerning how generative AI is going to explode our business on the product development side, on the product optimization side, and the happiness of our customers at the end of the day. We are going to talk for something different concerning AI, but not generative AI. Specifically, we're going to talk how straightforward AI practices like clustering modeling or regression modeling or propensity modeling, and of course, recommender systems, how these straightforward practices, which is a subpart of AI today, is crafting experiences for our customers. Now, first of all, I'm George. I'm a data scientist, and I work for an online betting domain. I work for OPAP. OPAP is a huge, pioneering, leading retail gaming company in Greece with thousands of stores across the Greek territory. And over the last 5 years, the company expands its business online. So what do we sell? We sell games of luck or games of skills, or to be more generic, I would say online entertainment. A fully competitive domain, a fully interactive domain with the customer, and a domain that creates an explosion of data for us. So, more specifically, regarding AI, we're going to talk about how clustering algos helps us to know our customer, how propensity algos helps us to foresee what the customer is going to do in the future, his tendency, how regression algos helps us to optimize a specific budget so as to maximize our new inflows of customers, and last but not least, how recommender systems helps us to craft specific and relevant experiences in a prolonged time for our customers. We want them every day to be more satisfied and more, let's say, to feel more close and more relevant with our tactics. So these 4 practices are not generative AI, but they are predictive AI, fully applied on customer analytics and fully applied on product feature development and optimization, and of course, proactive CRM, reactive CRM, or prescriptive analytics. So, before we go deep, and to be a bit more specific, there are 2 websites today out there. The first is opaponline.gr. It has all the traditional games that OPAP offers over the last decades. You can play it online from wherever you want, from whatever device you want, and however suits you. The other website, this website offers lottery games. So you can be a millionaire by investing only €1 through playing jackpot games. You can also play free-to-play games without paying anything and kill your time with entertainment. The other website is pamestihima.gr, which is serving to the customers live casino, casino slots, sports betting, and virtual games. As you can understand, this is an online domain that creates a big, massive need for understanding the customer from data and having the capability to predict what the customer intends to do in the future through machine learning. We are the online analytics and insights team. I have the privilege to be a member of that team, and we do 360 data science services for both websites. So this is what we are, okay? But today we're going to talk how we leverage this machine learning to satisfy our customers, to make our product owners look genius, to craft our products and features so as our customers have no motivation to play in the competition. First of all, clustering algos. The marketeers call them segments. The mathematicians call them clusters. We call them tribes. What is clustering algos? Clustering algos is a mechanism, a mathematical, a geometrical mechanism that splits thousands of customers in similar groups of similar behavior. Before going on how they work, let's understand what an online customer needs, the fundamental needs of someone to be able to bet with convenience, online, of course. So they need seamless experience from whatever device they play, mobile, the desktop, laptop, and so on. They need easiness to find their favorite game or what they want to bet. Of course, they need resolution of problems 24/7 out of effective call center. And by doing these fundamentals, the customers also need many gaming options because there are a lot of tastes and flavors out there. As they play and transact and invest money and they dream they win, they want to feel special, so they need loyalty points, cashbacks, free bets, discounts, whatever makes them feel that they take back what they invest. And last but not least, especially for the high-value customers, but for all of them, I would say, when they transact, they deposit, they withdraw, they need safety, speed, and transparency with their money. After moving forward from the fundamentals, let's see what clustering algos are trying to quantify. And I'm talking about 4 specific areas, let's say, of behavior of our clients that basically shape who is who they are, what kind of people they are, and what are their needs. First of all, the first thing that we quantify through a clustering algorithm is the game they prefer. Tell me the game you prefer, and I will say to you who you are. So there are people that are fond of betting on sports. Football is the king. They are football fans. They are on it on the weekends and on the Champions League Tuesdays or on the European Thursdays. If you like slots, then you like to kill time in multiple themes, in Sphinx, in the magical world of slots, let's say. So you need a fast and magic, let's say, prolonged time to spin your money and make winnings out of it. If you like to play live casino, you are a guy that performs skills. He likes the peer-to-peer battles. He likes card games, roulettes. Skills is the magic word for him. So basically, when the algo says to us, this customer prefers that game, it means that we know the backbone of his profile. And this is supplemented with his demographical profile, age group, gender, origin, and stuff like that. So we know the game he prefers, we know his demographical identity, and then we go on how he consumes our product. His spend level, his frequency of play, his style, his tendency to come back when he loses or wins. Many things are translated by the algo to fully quantified KPIs. Imagine a straightforward table with a customer being in the column and all the behavioral KPIs into the other columns. And we create a space for the algo to do its magic. But how these things work? Okay. What you see here is 2 boxes. Okay. Every customer has a quantified measure for its behavioral, let's say, aspect. 100 euros of spend, 9 days a month playing, 2 hours a day transacting, 3 or 4 deposits a day and 2 or 3 withdrawals. Every metric has its own axis, its own line. All these lines create the behavioral or the multidimensional space, this box over here. So the algo connects all these metrics and maps the customer within the multidimensional space. One customer is this blue dot, which is alone right now. The algo scales up and repeats this for all of our customers in seconds. So the algo is able to split the whole customer base into neighborhoods. Okay, so every cluster you see here with the same dots, with the same colored dots inside them, is basically a group of customers behaving almost the same way. The algorithm repeats and tries to shape borderlines and split the customers to similar groups. And he stops when the distance versus the clusters is maximized. What does this mean practically? This means that the business owners, the CEO, the CMO, the marketeers know that they can craft, that they can create differentiated commercial tactics, differentiated product features, differentiated CRM tactics, because they know that these customers are completely different, they like different things, and they spend in a completely different way. But how this geometrical, nice thing translates to practical commercial decision-making tool? The clustering algo feeds our reporting systems, our CRM systems, our production systems in general. And what the product owner sees as an end game. Within his reports, he sees, let's say, these are two clusters, two tribes. For instance, on the one side, we have a very few but very valuable guys or women that represent our VIP tribe. They are of very high spend, they play almost daily, they transact every day in a very dense way, meaning a lot of deposits and withdrawals. They like live casino, and they are dominated by millennial or boomer age groups, and they have very low female penetration. This is an example of a customer profiling as an end game of a clustering score. So the business owner, knowing all this information, adjusted with demographicals or other KPIs, they know that this tribe that is generating a very significant portion of our revenue has specific needs. What are these needs? Skill games, bonus features, peer-to-peer concepts. They want to battle with other skillful card players, let's say. Of course, they need special treatment, massive discounts, frequent discounts, and how can I say it? They are the golden tribe for us, and the algo says you need to treat him specially every day, even on a real-time basis, because if you lose one of them, you lose a very significant portion of your revenue. On the other hand, the other product owner has a different tribe to address. Suppose we have the blue tribe, the long shots. They are playing when a jackpot draw is coming. Here in Greece is on Tuesdays and Thursdays and Sundays. So we have people that they want affordably to dream big. So this is Laura. She spends low, she plays every other week, she's chasing the big jackpot, and of course this segment, as expected, is dominated by females and low-aged people. When the product owners, when the CRM guys, when the marketeers know how many are the customers of this tribe, what are the 360 view, the 360 characteristics of this tribe, then they can fine-tune their products, they can do relevant campaigns, they can do whatever they can to address these specific needs without launching horizontal campaigns. Okay. Another example are the sports fans. The sports fans are guys playing when football is on. Okay, weekends, Thursdays, Tuesdays, European leagues, domestic leagues. What are their needs? Their needs is dominated by football content, derby missions, they search for good odds, they do fun bets, they play for the favorite team, and so on. So, the clustering algo fits the production systems, and the decision makers can do different things for different people. And this is automated in the reporting systems and in the CRM systems. Now imagine that a CRM campaigner to us is taking the algo score within its system and says, launch the football campaign, and that's it. Because it's predefined on these needs. What is the driver of this? The clustering algorithm. Okay. So, we know our customer, but to make money out of it, we need to know what is his tendency, what he is going to do in the future. And this is when propensity algorithms come to the game. Before we go deep, this is straightforward machine learning practice so as to be able to foresee dangerous things like churn or opportunities like the potential of cross-sell or upsell for a customer. We will take the difficult example of reducing churn. Before we go on how they work, we first need to understand the scope. Suppose that the problem we want to resolve through propensity is to reduce churn. And of course, the money loss from this churn. We need first to understand which tribe creates the more money loss, so which portion of the churn is the most important. Suppose that the churn of high-value customers is the most important. Then the algo goes and see how Bob, let's say he's Bob, escalates his behavior until a point of time. The algo understands the pattern towards churn, and he assigns a probability to specific customers and flags them as high risk. So the investor, when he has an anti-churn budget, let's say, he can invest it on a targeted pool of customers and not launch a horizontal anti-churn campaign without knowing who is going to churn in the future. So the main goal here is to find these customers who have the tendency to churn in the future, and through a proactive campaign, to save as many as possible. Technically, how these things work, and I'm trying to be as much simple as possible and not so much statistical or technical terminology. How these things work. They take all of our customers, hundreds of thousands of them, and they list them. Okay. They are fed. We calculate and feed them to learn through specific categories of KPIs like spend, product preference, winnability, frequency of play, rewarding experience, and duration within our websites. We go in the past, we know who churned. See, January to March 25 is past. We know who churned. Before we go there, we create all this learning material for the algorithm. We see how the algo sees how the customers escalate behavior until a point of time. Then the algo sees, did John churn? No. Did this guy churn? No. Did Bob churn? Yes. Okay. So the algo says, Bob and all relevant Bobs will help me to learn future Bobs coming in, so to correlate this behavior and be able to predict whenever I see these signs, like Bob, I will escalate the probability of this customer to churn in the future. And as you can understand, this is very valuable, not only because it's accurate and it helps us to do proactive things, but also because it can be validated from reality. So an algorithm predicts all the Bobs through our customer base, and reality checks its predictive power. So there is no product owner that doesn't believe any data scientist who develops these kind of things, because reality confirms them. What's the end game? Basically, for all the customers, the algo chooses the more statistically significant KPIs that escalate and lead to churn. Okay? And this is an illustrative example of how an algorithm of this kind is. Okay? Let's say the algorithm chose statistically money loss play frequency, rewarding experience, winnability experience, and website downtimes. Suppose that the algo recognized these variables to be the churn predictors for the future. So the algo starts for every single customer in seconds and scales up for all the customers, and it works like this. First of all, does the customer lose above 100 euros a month? Yes. If yes, then the probability of churn goes up. The natural probability is 10. This customer has 15. Step 2. Does he lose a lot of money more than 10 days a month? If the answer is yes, then the probability escalates further. Step 3. Is his rewarding experience low at the same time? Meaning, is he taking discounts below 20% on his money loss? Then the probability goes even higher. And on and on and on, until you have a customer with 35% probability to churn in the future, which is more than triple versus the natural. So this information goes with the format of an ACE, of number 1, into our CRM systems, our reporting systems, and so on. So campaigners, product owners, decision makers in general know in advance which customers are going to lose in the future. As we said before, they know their segment and profile, so they can do a relevant and a spooky relevant campaign so as to prevent the tendency of the customer to churn, so they continue to play. And this is one form of disruption. Basically, it has a lot of benefits. They are self-explanatory. Imagine that you had 100,000 euros budget to reduce your churn. If you didn't know anything, you would invest this money across your customer base. And basically, the more simple thing to say is that your customer would feel, if you had 100,000 customers, would feel €1 benefit. If you followed the model and took, let's say, 10,000 customers only who have high probability to churn, then your investment would make your customers feel not €1, but €10. So I won't extend much on that. Propensity algorithms can be expanded not only for anti-churn reduction, but you can predict the tendency of the customer to play more products. You can predict the tendency of the customer, let's say, to become a VIP in the future. Many applications that we use and apply in OPAP on a daily basis so as to craft, the ultimate mission is to craft relevant, fast, and satisfying experiences tailor-made for specific profiles. Now, marketeers, they come in and say, I have 10 million budget, let's say, to maximize my registrations, my new customers in. So, my budget has many opportunities. I can invest on ATL marketing, above the line. I can invest on affiliates marketing. I can invest on digital marketing, and so on. Give me the magical equation that will say to me what % of investment to put to each marketing driver so as to maximize my customer inflows. And of course, the data scientist develops a regression model. What is a regression model? It goes historically. He takes the mix of investment. It observes the actual customer inflows. It learns to predict the customer inflows given the marketing mix. And we leave a specific period of time for the model to forecast. We check the model if it forecasts more or less close to reality. And the model says, finally, paid search investment is Z% responsible for your inflows. Affiliates, L%, social media, D%. This is your baseline sale, so even if you didn't go to work, you would register this kind of customers. And of course, one portion of your new customer inflows are unexplained by the model. So the marketeer knows what's the impact of each customer driver so as to accelerate the scale up or reduce the investment to a specific channel. And of course, he can play with different investment mix scenarios, and he will know in advance what will be the customer inflows in the future given the marketing mix. We know the customer. We can predict his tendency. We can optimize our marketing investment because we know what impacts their decision to register with us. Okay. What do we do now? And we jump in to recommender systems. Okay. Recommender systems seem magic and black boxes, but they are not. Given that I know the profile, given that I know the probability to do something in the future, there are more or less massive if-then-else statements that are crafting specific experiences for specific people on a daily basis. Okay. Look at this example. John is a sports fan. It's Monday. He takes a break from the weekend betting activity to football. On Tuesday, the recommendation engine sent him a reminder. On Tuesday, there is Champions League, my friend. John bets 50 euros and loses it all on Champions League. Wednesday, the recommender system returns back 10 euros free bet to bet on the cup final on Wednesday. John neglects it. Okay. Thursday, the algo tries to cross-sell John, who didn't play in the cup final, to casino, and he gives 5 free spins to play. John doesn't react again. Friday, the algo says, he doesn't react. I need to hold on. I did my efforts. But on Friday, John plays the free bet the recommendation engine gave him on Wednesday. So he bets on basketball and he massively wins 500 euros. See? The algo says, John won. I will hold and see what he will do. Okay. So Saturday, nothing given to John. John gets excited, bets he's winning, and loses 800 euros. No worries. The algo returns on Sunday 250 euros back, which is more than 30% discount, right? John, he steps back, he receives the money, he bets normally 50 euros and withdraw the other 200. Okay, that's a normal behavior. But he didn't churn, he's there. Monday, okay, he withdrew 200 euros. Will we go crazy? No. The recommender system sends a sign to the call center and they call him and say to him, hey, John, you won the jersey of Man United, which is your favorite team. Monday, no football, no nothing. John takes the call and says, Man United is my favorite team, thank you very much. And this goes on and goes on and goes on for a lifetime. And me as an analyst, I program it through some if-then-else statements, specifically for this profile, and I'm sitting and observing John. So guys, this is not generative AI. This is not magic. This has been applied in years now, but now the spotlight and the usability within companies is massive. Straightforward machine learning practices, the fact that they are straightforward doesn't mean that the company is adopted 100%, all right? We are 13 analysts so far in the online business of OPAP. We were 2 heroic analysts 5 years back, and now this is 50% of our time. Now, what I want to say as a closure to this is that we are bombarded with AI content. This is going to change our lives. We've seen great presentations previously with great examples of application. Generative AI is doing things that are spooky, okay? Smiley faces. I'm asking something, I take the response. Even my analyst asks ChatGPT to write code for them. But what we've seen here is the other side of AI. This is machine learning for customer applications. I believe we've observed that, and it is a fact, that when a company shifts machine learning on a practical way, focuses on the need of the customer, quantifies the profile, calculates the future action, and proactively trying to disrupt a negative intention of the customer or scale up a positive intention of the customer, then machine learning ROI comes to the game. We look successful, product owners look successful, and everything is fun. And the last statement I would make, generative AI or predictive AI are fundamentally mechanisms that look magic to us today, okay? But if we have a lack of business thinking of their usability, they will always give back wrong answers or no answers. So analysts, data scientists, machine learning experts need to be hand in hand with commercial profiles and product owners and CRM experts and marketeers. Basically, that was all for today, and thank you very much for having me here.
Thank you.